In Chapter 6. It's the foundation for everything that we're going to be doing in Chapter 6, which brings back some of your algebra skills of proportions and cross multiplication. Ladies. So if we think about what a ratio is, what is a ratio?
Fraction.
It's a fraction.
A piece of a whole.
Sure. So if we think about a ratio as a comparison of two quantities, let's think about actual ratios that are out there in the world. If I say
boy-girl ratio.
If I say MPG, what does that mean? Miles per gallon. If I say MPH, miles per hour. If I say PSI. Well, what does it act? What are the words? Yeah, pounds per square inch, right? It's your air pressure in your tires. You guys know that? Now you do. PSI. What about BPM? Yeah, beats per minute, right? When you're in gym class. Okay, Michaela, quiet please. When you're in gym class, you check your heart rates. It's your beats per minute. What's another one? When you go to the grocery store. Do you guys go to the grocery store? Hopefully you go to the grocery store. And they have on the shelves where the products are, they have the price. But then do you ever look at the unit price of the product? What does that unit price mean?
Per pound.
It's per like one unit of whatever it is. So for example, if you go to the grocery store and you buy some Charmin Ultra Soft toilet paper 3-pack, it's some price, right? Or they have a 24-pack. It's going to be more expensive, but which is going to have the better unit price? The 24-pack, okay? So that's why sometimes buying in bulk is good. Some people are members of BJ's. They get things in giant bulk because in the long run, it's cheaper unit price-wise as opposed to buying something less. Okay, so rates. If we look at this example here, we have a scale model of a car. It's 4 inches long. The actual car is 15 feet long. What's the ratio of the length of the model to the length of the car? Well, how do we write that out?
So we have to make a both inches.
I like that idea. So if we have 4 inches, and like Michaela said, it looks like a fraction, over 15 feet. Which would be easier to convert? Inches to feet or feet to inches in this case? Well, we could. If it was 12 feet, that would be really, if it was 12 inches, I could easily take that to 1 foot. But in this case, I don't have a very nice number, so let's take feet to inches. So if I have 15 feet, times 12 to get to our inches, so that becomes 4 inches, what does that get us? 10, 2, 3, 5, 1, so 185? 180? Did I do that right? 180 inches. Can you reduce that fraction?
180 divided by 4.
Does 4 divide into 180 nicely?
I don't know.
4 goes into 18. How many times? 4, remainder of 2. So yeah, it does, right? So 1, so what is that? 4, 16, 20, so 45. So my ratio is, for every 1 inch, it represents 45 inches. Now there's different ways to write ratios. What's a different way to write that ratio? Freddie?
I think there's like a colon.
Yeah, the colon. So we could do 1 inch colon 45 inches. Sometimes they use the actual word to. So 1 inch to 45 inches would work. Just different ways. You can write it however you want. Probably writing as a fraction is going to be your nicest trick because as we get into solving proportions, you're going to want it to be a fraction. Okay, so we're good with ratios. So on your homework, you're going to have to do some simplifying of ratios, which means you're going to have to convert to like things. How many quarts are in a gallon?
9.
4 quarts in a gallon. Don't just shout out things, please, Michaela. 4 quarts to a gallon. How many cups are in a pint? 2. 2, right? 2 cups in a pint. So then how many cups would be in a quart? 4. Good. Okay, there is in our textbook all those different conversions. I forget what page it is on, but I can look it up if you get stuck on your homework. Okay, so what is a proportion? What's a proportion?
A part of a whole.
No.
Oh, that's proportional.
So in algebra, do you remember cross multiplication? You use cross multiplication to solve proportions. Two fractions that are equal to each other. Good. So a proportion is a statement that 2 ratios are equal. So you're used to seeing proportions that just have 2 ratios. When we get into triangles, we no longer have just 2 sides, we have 3 sides. So we get into things that are called extended proportions. And an extended proportion is just a proportion that has 3 or more ratios that are equal. So when you have an extended proportion, it's when 3 or more ratios are equal. We won't usually go more than 3 because we're stopping at triangles. All right, and then the last one for this set is the cross product property, which is what your cross multiplication does for you when solving proportions. If I were to give you the proportion, is everybody good? Wait, 3 seconds. 3, 2, 1. Good. All right, if I give you the proportion A over C is equal to B over D, and I asked you for the cross products, would you know what that means?
A times B equals C times B.
Right, so your cross product, that would be one cross product that I circled there. So it would be A times D, which would just be AD. Yeah. Your other cross product would be B times C, or just BC. And what the cross product property says is that we can then equal your cross products, which ultimately is your cross multiplication. You guys remember doing that in algebra? So when we look at the different things that you can do to manipulate ratios in the next example, we're going to keep checking our cross products to make sure they stay the same. So if we give you, we already did that, the proportion x over y equals 5 over 6. 6x is one of the cross products. What's the other one? 5y. So my cross products should stay the same no matter how I manipulate my ratios. Well, if my original ratio was x over y, what happened to it in part B? It flipped. So this one should then turn into 6 over 5. Did my cross products change? No, I still have a 6x, I still have a 5y. If I didn't remember to flip it and leave it as 5 over 6, now did my cross products change? Yeah, so I know that that's wrong. So I should check my answers to make sure it is correct. All right, let's look at C. What's happening? It took x over 5.
Y over 6.
Good, y over 6. Check your cross products. Did they change? Nope, so we know we did it right. All right, now this one gets a little bit trickier, because now what's happening to the ratio here?
6 plus 5 over 5.
Good. I'm going to write it out 5 first. So we're taking our normal ratio, which is 5 over 6, and we're adding the denominator to the numerator. So I'm going to add a 6 there. 5 plus 6 simplifies to 1 over 6.
Wouldn't that be a 5 since the last one?
No, because your y is the original denominator.
Oh, okay.
So you're adding denominator
Oh.
to the numerator. Adding denominator to numerator. Okay?
So it's 5
plus 6 over 6. All right, flip on to the back. Let's try some of our algebra skills, and then we'll pause and make sure we're good with cross multiplication before we move on. So for A, what do I get on this cross product? 7x, and the other one would be 5 times 12, which is 60. Good. So then we get 7x is equal to 60. Divide by 7. Now this is going to bring up a good topic of discussion that I want to throw out there. Does 60 divided by 7 nicely? No. If I were to type 60 divided by 7 into my calculator, because you're going to want to do that, what I end up getting is 8.57142857.1. I do not want you to round if you get a decimal that does not terminate. When I say that, do you guys know what I mean? So terminating decimal would be something like 2.5. The decimal stops. Or 22.555. Decimal stops. If I had 22.1428765153552, and it keeps going, and it doesn't stop, then I want you to write it as a fraction, because we don't want to round our answers. If it was 22.333 repeating, what does 0.3333 really represent as a fraction? You guys know that? It's a third, right? If it's 0.666666666 repeating, what's that? That's 2/3. 1/6 is 0.1666666. That's 1 over 6. Okay, so if you know those, then write them as a fraction. If all else fails, just leave it as a fraction and see if you can reduce it. So 60 over 7, I cannot reduce. So I'm just going to leave it as 60 over 7. So it's a non-terminating decimal. So you want to give exact answers is the theory behind it. All right, let's look at B. This cross product is the easiest one. 8 times y just gets us 8y. But now it happens on the other cross product. Yeah, you have to make sure you multiply 4 to both the y and the 3. Errors occur when you just multiply the y by 4. So now we get 8y equals 4y plus 12. Subtract 4y. I like that idea. 4y is equal to 12. Dividing it gets us y is equal to 3. Okay, so we're going to pause for a second. We went through all the different cross multiplications. So now let's talk about scales and scale drawings. We're going to do a little bit more on this tomorrow in class. We need to make sure we know what a scale is, and when I say the word scale, what it means. So when we have a scale, scale is the ratio of any length in a scale drawing. So the ratio of any length in a scale drawing to the corresponding actual length. So in that definition, it talked about what a scale, well, it talked about a scale drawing. So what is a scale drawing? It's a drawing in which all lengths are proportional to corresponding actual lengths. So you just practice solving proportions. So now you should be able to set up proportions for proportional lengths. So if you think about maps are scale drawings. It's a smaller picture of a country or whatever it is you're looking at. Architects use blueprints. Those are scale drawings. If they were to make a blueprint of the size of this room be the size of this room, that would be a giant piece of paper that they would have to have, right? So they reduce things, take it down to scale. So if we look at this first example, it says 2 cities are 3.5 inches apart on a map. The scale says for every 1 inch, it's 50 miles. Now this one's pretty easy to figure out without setting up a proportion, but let's do it just for fun. If I turn that scale into a ratio, 1 over 50. Keeping in mind my 1 represents inches, my 50 represents miles. I want to know how many miles 3.5 inches represents. So is the 3.5 going to go in the numerator or the denominator? The numerator, and my x is going to go down here. So that gets us 175 miles when we cross multiply it. And the last type of problem that you're going to see on your homework, we're going to not get to geometric mean today, is the next problem. Given an extended proportion, so now we have a triangle whose side lengths are 6, 8, and 12. So if you make a quick triangle at 6, 8, and 12, it's telling me that my triangle's perimeter must be 130 feet. How do we find perimeter? Add up all the sides. Do these add up to 130? No. So there has to be some scale or some multiplier that makes it there. If I were to just double them, 12, 16, and 24, those still don't add up to 130. Tripling it still doesn't get you to 130. So in algebra, when there's something that we're looking for that we don't know what it is, we use a variable. In this case, we'll use x. So let's set up an equation. 6x plus 8x plus 12x equals 130. Combine like terms. 26x equals 130. So x is, huh?
Nothing.
You okay? So that gets us to 5 is my multiplier. So that means my side length, 6 times 5 is 30 feet. 8 times 5 is 40 feet. 12 times 5 is 60 feet. So those would all reduce down to the ratio of 6, 8, and 12. And those add up to 130. On your homework, really quickly, hold on guys, I still have 2 minutes. On the homework, instead of a triangle, they might give you a rectangle. So they might just give you 6 and 8. But keep in mind, a rectangle has 4 sides. So you would have to add up 4 terms. So 6x plus 8x plus 6x plus 8x equals 130. And it talks about the area. Then you would multiply 8x times 6x and equal it to the area. All right, so you are finishing up